Okay, so today's notes are on more linear equations. So we did slope-intercept yesterday. Today we're going to talk about other forms. Our content objective is to write an equation of a line given its slope and a point on the line, and our language objective is to define slope-intercept, point-slope, and standard form of a line. So we're going to jump right in and start talking about the different forms that I just mentioned. So slope-intercept form we talked about yesterday. So just quick refresher, it's y equals mx plus b. M is the slope, B is the y-intercept. And we can use this, or we definitely want to use this when you know, or when we know slope and the y-intercept. So if we have the two bits of information we need, obviously we want to go with that form. It's probably the one you're most familiar and comfortable with, but there are other types as well. So another form of a line we're going to work with is point slope form. And sometimes students get intimidated by this one, but it's actually one of the easier ones to work with. It's y minus y1 equals m parentheses x minus x1. And so we use this when we know, or when you know the slope and a point on the line, or 2 points on the line. So this, again, m here is our slope. So m in all of these equations will be our slope. But then x1 comma y1 is just a point on the line. So this can be really easy if we have just a point and the slope, or 2 points, we can find the slope and then plug in the point, and it's actually one of the easier ones to work with, like I was just mentioning. We'll do an example of that one in a minute, but that is point slope form, y minus y1 equals m parentheses x plus x1. Last but definitely not least is standard form of a line. So there are standard forms of lots of different equations, but standard form of a line is ax plus by equals c. And again, usually we don't start with these, or we don't write standard form from a graph. We usually begin with this form from a word problem. So usually we're not starting with standard form from a graph. Usually we're starting with standard form from a word problem. The only other thing that this is helpful with is it's good to use to find intercepts. So it's helpful when we're finding intercepts because we can just plug in 0 for x or 0 for y to solve for the other intercept, which we'll do an example of in a minute. The only other thing I need to mention is a and b cannot both be 0. So they can't both be 0 if it's going to be a line, and a, b, and c are all real numbers. So you can't use imaginary numbers. We haven't even learned about imaginary numbers yet, so I won't worry too much about that, but it only works if A, B, and C are all real numbers. So as promised, I want to start with an example of point slope form. So start with point slope form. And we're going to do an example. I want us to write the equation, or write an equation for a line that goes through 3, 2, and 5, 8. So we're going to jump in with this example. The first thing we need to do, so again, we're starting with 2 points from our line, so we know point slope will be the easiest one to use. We still always need to start by finding slope. So almost every situation you're going to start by figuring out what slope is. So again, if it's helpful, you can label your points, but I'm just going to do, I have 3, 2, 5, 8, x1, y1, x2, y2. So I have 8 minus 2 over 5 minus 3. If I simplify that, 8 minus 2 is 6. 5 minus 3 is 2. 6 divided by 2 is 3, so my m value is 3. So I now know my slope. Now this part is really easy. All I need to do is substitute. And when I substitute, substitute m, and I can use either point, so I get to choose one or the other to substitute in for x1 and y1. So if I chose 3, 2 to plug in, then my equation would be y minus 2 equals 3, my m value, times x minus 3, because I'm just plugging in x1, y1 into that point. I could use the other point, however, it really doesn't matter which one you use. It can work with any point on the line, which is why this one is one of the easier ones to work with. But I would have y minus 8 equals 3 times x minus 5. So these are both acceptable answers for point slope form. You can choose whichever one you'd prefer for that equation. So that's our example of point slope form. I'm going to flip the page and talk about slope and solving for intercepts. But while I do that, I want you to send me an email again at kleary@k12.somerville.ma.us. So send me an email. Please tell me you're listening, and I'm going to continue on with the notes. So solving for intercepts. Just a refresher what intercepts are. It's where they cross the axes. So if this is my x-axis and my y-axis, I had a linear equation. Now, this is true for functions that are not linear. Intercepts by definition are where they cross an axis. So this here would be my y-intercept. This here would be my x-intercept. And this is true, again, we call these intercepts, whether this is a linear function, a quadratic, or any other function, where it crosses the axis is an intercept. And what I'm about to tell you is true for every single function we'll learn about this year. We can always solve for our x-intercept by substituting zero for y. So we can say y equals 0. So when y equals 0, that's when it crosses the x-axis, because all the y values up here are positive, all the y values here are negative. So my x-intercept, by definition, y will always, 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 always be 0. So whenever you're solving for your x-intercept, you plug in 0 for y. And the opposite is true. So you can solve for your y-intercept by substituting 0 for x, or x equals 0. So when x equals 0, you can get your y-intercept. So if you plug in 0 for x, you will get your y-intercept every time, every function. It always works. So we're going to do a quick example of that. I'm asking, what are the intercepts of 3x plus 5y equals 15? So the first one, we'll do our x-intercept first. First thing, we substitute y equals 0, Substitute y equals 0, and then we solve for x. So if I substitute 0 for y, I get 3x plus 5 times 0 equals 15. 5 times 0 is just 0, so I have 3x equals 15, x equals 5, so my x-intercept would be 5, 0. So again, since I plugged in 0 for y, I know I just solved for x. There's my x-intercept. So that's why I said standard form, which is what we started with here, can be really helpful for solving for intercepts, because it automatically cancels one out and then you just have to divide. It makes life really easy. So the next one, if I'm solving for my y-intercept, I substitute 0 for x, and then I solve for y. So the same deal here, only this time we have 3 times 0 plus 5y equals 15. 3 times 0 is just 0, so I have 5y equals 15, so y equals 3. So then my coordinate point would be 0, 3 for my y-intercept. Makes life super easy. All right, so that's it for intercepts right now. Make sure you write down any questions, comments, concerns you have on this. And I'm going to flip the page just so I have plenty of room for the last concept we're going to talk about today, parallel and perpendicular lines. So parallel, I mentioned these briefly yesterday in yesterday's notes. So parallel and perpendicular. So parallel and perpendicular lines, as I mentioned, I'm going to choose a little table here. Our slopes are equal. So they're exactly the same. Slopes are equal in parallel lines forever and always. But the y-intercepts have to be different. If they were the same slope and the same y-intercept, then you just have the same line. So they have to have different y-intercepts to be parallel, otherwise you end up with just the same exact line. So visually, these could look something like this. So we'll call this M1, M2, B2, B1. So then we know that M1 equals M2, so the slope of the first line is equal to the slope of the second line, but B1 does not equal B2, so the y-intercept here does not equal the y-intercept here. Otherwise, that would just be the same exact line. All right, so the other one we want to talk about is perpendicular. So I mentioned these yesterday as well. Perpendicular lines are negative reciprocals. So, sorry, I meant to write this first. Slopes are negative reciprocals. And what that means is that you flip and negate. So I'm putting a little star here. You flip and negate the slope to get the perpendicular slope. So you flip and negate. So what they look like visually before I go any further, if you had these two lines, we'll call this M1, this M2. They intersect at a 90-degree angle. That's why I drew that little sign in. So they're intersected at a 90-degree angle. And M1 times M2 would equal -1. Because they are negative reciprocals, they cancel each other out such that when you multiply them, they equal -1. So there's a bunch of different ways you could rearrange this. M1 is equal to -1 over M2, or the opposite, M2 is equal to -1 over M1. So really all we have to do is flip and negate to find our perpendicular slope. So I'm going to do an example of that so you can see exactly what I mean. I'm going to ask us to write the equation of the line perpendicular to y equals -4x plus 2 over 3 that goes through the point, or goes through 8, 5, and I want us to write this in slope intercept form. So this is our goal, to write the perpendicular line to this that goes to this point in slope intercept form. So the first thing we need to do is determine slope. So for all linear problems, we're always going to start by determining slope. So in this case, I can do that by looking at my original slope. So I have -4. I'm going to flip it. So my first step, I flip it. I have 1 over -4, and then I'm going to negate it. So I change the sign, and it becomes positive 1 over 4. So my new slope is going to be m equals 1/4. So my new slope is 1 over 4 because I flipped 4, it became 1 over 4, and then I changed the sign, so it became positive. Then I'm just going to substitute, because I have a point in the slope, I'm going to use point slope form. So I'm substituting into point slope form. So when I do that, I have y minus 5 equals 1/4 x minus 8. So I just plugged in my points from over there, or my point from over there for x1 and y1, substitute into point slope form. Then I'm going to put it into slope intercept, which is where I want to end up. So I always start with, or I can start with point slope and then rearrange or isolate y. And I'm going to do that by distributing. So I distribute 1/4 in, and I get y minus 5 equals 1/4 x minus 8 times 1/4 is the same as 8 over 4, which is -2. So -8 times 1/4 is -2. And then I'm going to add 5 to both sides. And I get y equals 1/4 x plus 3, and that is slope-intercept form, so I'm all set. So the perpendicular line to this that goes through this point would be y equals 1/4 x plus 3. All right, that's all for today. Make sure we write down any questions, comments, or concerns you have so we can go over them together in class.